In this video, we'll focus on how to find the volume of prisms and cylinders. So a prism is a polyhedron with two congruent faces called bases that lie in parallel planes. The other faces, called lateral faces, are parallelograms formed by connecting the corresponding vertices of the bases. The segments connecting these vertices are called lateral edges. The altitude or height of a prism is the perpendicular distance between its bases. In a right prism, each lateral edge is perpendicular to both bases. Prisms that have lateral edges are not perpendicular, or that are not perpendicular to the bases, are called oblique prisms. We will only be studying right prisms though. Both of these shapes are considered to be right prisms because the bases are our congruent faces. So like in the left prism, our base shape would be a square. And so our bases are on the top and the bottom in this particular prism. On the shape on the right, this would be a triangular prism because our bases are on the ends here and here. So our bases would be here and here, here, and here. The other sides would be lateral faces. So this would be a lateral face. This would be a lateral face. This would be a lateral face. And so would this. This one has a lateral face here, and here, and there. Lateral edges would be here and here, here and here, 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 and here. These lateral edges would also be our altitude or our height in these right prisms. So prisms are classified by the shape of their base, so in number 11 and number 12, it asks us to name each right prism and then label its base and its height. So this particular prism would be a rectangular prism. Our base would be the rectangle at the bottom. And our height would be this tiny lateral edge on each of the corners that connects the two bases. In number 12, our base would be a hexagon, so this would be a hexagonal prism. So our base would be the hexagon, and our altitude or our height would be what connects the two bases. A cylinder is a solid with congruent circular bases that lie in parallel planes. The altitude or the height of a cylinder is the perpendicular distance between its bases. And the radius of the base is also called the radius of the cylinder. So in a cylinder, our base would be the circles. Our height is going to be perpendicular to the bases. So it would be like if I dropped down a perfectly straight line from the center point of my circle. And so this would be the height. Or the altitude. And then the radius would be the radius of the circle. So next we're going to talk about the volume and what the volume is. So the volume of a solid is the number of cubic units contained in its interior. So volume would be like if we were taking these 3D shapes and we were filling them up with some kind of substance. So your volume formula for prism and a cylinder is going to be essentially the same. So the volume of a prism and a cylinder is going to be equal to the area of the base times the height. So the big B here is going to be the area of the base. And so that will change depending on what the shape of your base of your prism is. For a cylinder, you're going to use the area formula for a circle, which is pi r squared. So where the r stands for the radius, and the h is going to be the height. So on example 13 through 16, it asks us to find the volume of the solid. So for this one, it looks like our base is a rectangle. So when we do our formula, our volume formula, big B times h, big B would be equal to length times width of my base. The h would be equal to the height that connects my two bases. So my base would be this rectangle at the bottom, the 2.5 millimeters times 3 millimeters. So 2.5 times 3. And the h would be the height that connects those two bases, which would be 5.5. So that means that for my volume, I'm going to say 2.5 times 3 times 5.5. So 2.5 times 3 times 5.5 gives me 41.25. But because it's volume, we have to use our units and we have to cube them. All right, for number 14, we have a triangular prism. So that means we're going to say V equals big B times H. Big B is going to be equal to the area of a triangle, which is 1/2 base times height. And so when we plug into our formula, we're going to say 1/2 times the base of our triangle, which is 2.5, times the height of our triangle, which is 6, times the height that connects the two bases, which is going to be 3. So when you plug that into your calculator, you should get 22.5 feet cubed. On number 15, it says leave your answer in terms of pi, and so you are finding the volume of the cylinder. And so the volume for a cylinder is going to be big B times H, where big B is going to be equal to pi r squared. And so when you plug into that formula, you need to know that r is going to be 8. And so you're going to say volume equals pi times 8 squared times the height. And so because it says leave it in terms of pi, we just need to multiply 8 squared times 5, so 64 times 5. And that will give us 320, and we're going to leave that pi in our answer. So remember, it's going to be meters cubed for our units. And then number 16 says leave your answer in terms of pi again. And so this time, though, it gives us an entire diameter, but we only need the radius, so we only need from the middle to the outside. And so if the diameter is 12, that means that the radius would have to be 6. And so when we plug into our volume formula, because our base is a circle, that means we're going to say pi r squared. And so we're going to say volume equals pi r squared times h. And our r is going to be 6 and our h is going to be 9. So that means r is 6, h is 9. So our formula is going to look like pi times 6 squared times 9. So we're leaving it in terms of pi. So we're going to say 6 squared, which is 36 times 9. And when we do that, we get 324. So 324 pi inches cubed would be our answer. All right, so you try number 17. So on number 17, you're asked to find the volume of a cylinder. So volume of a cylinder is going to be big B times H, where big B is the area of the base, which is the circle. So that would be pi r squared. So you need to know that your r is equal to half of the diameter. So if the diameter is 10, then that means that the radius is 5. And you need to know that your h is the height, which is 16. So that means that whenever you plug into this formula, you're going to say volume equals pi 5 squared times 16. So we are leaving it in terms of pi, which means that we just need to do 5 squared times 16, so 25 times 16. And that will give us 400 pi feet cubed. All right, on numbers 18 through 20, we are going to be using our formulas to try to help us find out other information that they don't give us. So on number 18, it says, what is the radius of a cylinder with a height of 5 inches and a volume of 62.8 inches cubed? Round your answer to the nearest inch. So we know that we're dealing with a cylinder, and we know that we're dealing with the volume of that cylinder. So our volume formula for cylinders and for prisms is V equals big B times H. But we know that our shape is a cylinder, which means that our big B is going to be equal to pi r squared. So that means that our formula for this cylinder would be V equals pi r squared times H. Now, it tells us that our volume, which is V, is 62.8. The pi will stay. We don't know what R is, but we do know that H is 5. So when you go to your calculator, do alpha y equals to get your fraction. You're going to do 62.8, and on the bottom you would do 5 pi. So your pi button is going to be second, and then your caret, and whenever you do that, you're going to get essentially 4, so we'll call it 4. So we're going to say that our r squared would equal 4. But remember, we're trying to get r by itself, so we would square root both sides, and that would give us that our r would be equal to 2. So our units for our radius would be 2 inches because of the units in our volume that told us that it was inches cubed. Our radius, however, would just be in inches because we always measure volume in cubics, but we don't just like regular measurements like the height or the radius. Number 19 says, what is the length of a rectangular prism with a volume of 576 centimeters cubed, a height of 6 centimeters, and a width of 8 centimeters? So we know that we're doing a rectangular prism, and we know we're talking about volume. So we're going to say volume equals big B times H. But because our prism is a rectangular prism, that means that our big B would be equal to length times width. So when we plug into our formula, that would be volume equals length times width times height. So it tells us that our volume is 576. We need to figure out the length, but it tells us that our width is 8 and our height is 6. So in order to figure out what our length would be, we would say 576 equals 48 times length. And to get length by itself, we would divide both sides by 48. So when you divide both sides by 48, you're going to get that your length is equal to 12. And so based on the units used in our problem, our length would be equal to 12 centimeters. And number 20 is a little bit more difficult. It says calculating the volume of air in your home can help you determine how much heating and cooling your home will cost. Farmer Joe wants to find the air volume of his barn. The height of the barn at the highest point is 35 feet, and so we can see that on our picture. Help Joe find the volume to the nearest cubic foot. So if we think about this barn, our barn we could break up into two different shapes. Two different solid shapes. So if we split here, we could have a triangular prism in the roof, and we could have a rectangular prism in the barn part. So that means that our total volume would be equal to the volume of the triangular prism plus the volume of the rectangular prism. So for the triangular prism, our volume would be equal to big B times H, but our big B, because it would be a triangle, would be 1/2 the base of the triangle times the height of the triangle times the height of the entire prism. Our rectangular prism would also have the same formula, But this time our big B, because our base would be a rectangle, would be length times width times height. So, looking at our entire shape, we know that from the ground to the top of the roof is 35 feet. But we know that the walls of our barn are 20 feet. So if the entire height of the barn is 35, but the height of just the walls is 20, if I said 35 minus 20, that would give me the height of just the roof part. So 35 minus 20 would give me 15. Now, the roof part still has a length of 40 because it's still the same length as the base of my barn. So when I plug into this formula, I'm going to say 1/2 times the base of the barn, which is 40, times the height of the roof, which we said was 15. And then the height or the altitude of the entire triangular prism would be the distance between the two bases, which is going to be the same as the distance between the two bases of my walls. And so that would be times 80. Alright, so then we'll move on to our rectangular prism. And so our length of our rectangular prism is going to be 40 times the width of our rectangular prism, which is going to be 20, times the height connecting my two bases, which would be 80. So for the triangular prism, 1/2 times 40 would be 20, times 15 would be 300, times 80. 300 times 80 would be 24,000. Alright, for the volume of the rectangular prism, which would be the bottom part of the barn, I would say 40 times 20 times 80. 40 times 20 would be 800 times 80, and 800 times 80 would be 64,000. And so when I add those two numbers together, it's going to give me my entire volume for the barn, which in this case would be 88,000 feet cubed. Feet cubed because it's volume.